Hello fabricators, how are you doing? In the last video, we saw how to load on-prem data to Microsoft Fabric with Dataflows Gen 2 and on-prem data gateways. In this video, I'm going to show you how to load on-prem to Fabric with Synapse Spark. Let's get started. What I have here is an on-prem SQL Server with AdventureWorks database running on a Windows machine with a private IP address of 10047. Now, we are going to load the customer table from this database into Microsoft Fabric. On the Azure side, I have a virtual network with an address range of 192.168.00/16. Now, this virtual network is connected to my on-prem network via a VPN gateway. It could also be an express route in your case. What I also have is a Synapse workspace with managed virtual network enabled. Loading from on-prem to Fabric with Spark is going to be a 5-step process. Step 1, we are going to create 3 different subnets in our virtual network. Step 2, we are going to put up an IP forwarder in our backend subnet to talk to our SQL Server. Step 3, we are going to put a load balancer in the front-end subnet. And step 4, we are going to put a private link service in our TLS subnet. And last and the final step, we are going to connect our Synapse managed virtual network to the on-prem network via managed private endpoint. Once we have this set up, then we can load the data from on-prem SQL Server using Synapse Spark and load it into Microsoft Fabric Lakehouse. I know what you're thinking. Hey, this looks too complicated for me. But don't worry. I'm going to walk you through step by step and make it really simple for you. So let's head over to our VNet and start with step 1, which is creating the backend subnets. Now I'm in my VNet. I'm going to start by creating 3 different subnets. Let's go to the subnets and click create subnet. And I'm going to call this as backend subnet. Leave the address range and all the other options as it is and click save. Next, we are going to create the front-end subnet. Leave all the other options to default and click save. And finally, we are going to add the PLS subnet. Now we have our 3 subnets created. Now let's go ahead and create the IP forwarder. But wait a minute. What is an IP forwarder? An IP forwarder is nothing but any device. It could be a VM or a router that has a network interface. What that means is it is capable of receiving the data and sending the data on a specific port number. Let's take an example. If device A wants to talk to device B, what this IP forwarder does is it receives the packet from device A on a given port number and sends those packets to device B on a given port number. In the same way, it receives the packets from device B on the given port number and sends it back to device A on the given port number. The protocol that it uses for the sending and receiving these packets is called TCP. One thing to note here is, unlike a data gateway, this IP forwarder is not going to read the data from device A and write it into device B. It simply forwards the packets from device A to device B using the network interface. So, for an IP forwarder, you don't need a machine with large amount of CPU or memory. All we need is a good network bandwidth. Now I am back in my Azure portal. I'm going to create a new virtual machine to use as my IP forwarder. So let's go ahead and create the virtual machine. Let's give a name for our virtual machine. Select the region and I'm going to be using a Ubuntu server as my image. Now our VM has been successfully created. Now that we have our Azure virtual machine created, it's time to set up the IP forwarding from this Azure virtual machine to our on-prem SQL Server. For that, I'm going to log in into my Linux virtual machine. I'm going to be executing a bunch of shell scripts. But don't worry, I'm going to give all the shell scripts in the description below. Now, I'm in my Linux virtual machine. I'm going to log in as root user. For that, I'm going to be using the command sudo su-. Now I'm a root user. The first thing that we are going to do is to enable IP forwarding on this Linux virtual machine, and that can be achieved by executing this command Let's go ahead and execute this command. Now, IP forwarding has been enabled on this Linux virtual machine. In order to do the port forwarding, we need three details. The first is the Ethernet interface card in which we are going to receive the packets. In my case, I have only one network interface card attached to this virtual machine. So I will be using ETH0 as my network interface. Here I have declared a variable called ETH_IF and I have assigned ETH0 as the value. The next detail that we need is the port number in which we will be receiving the packets. In my case, I will be receiving the packets in port 1433. So I am declaring a variable called fe_port and I am assigning 1433 as the value. The next detail that we need is the destination IP address. This is the IP address of the on-prem SQL Server. I'm going to be declaring 10047 as my destination IP. The final detail that we need for the port forwarding is the destination port number. This is the port number in which we are going to forward the packets. In my case, I am going to be using 1433, which is the default port for SQL Server. Here, I am using the iptables command to create a network address translation rule to forward the packets from this Linux virtual machine to on-prem SQL Server. And I am also creating a rule to receive the response back from my on-prem SQL Server. That's it. With these two commands, we have successfully created the IP forwarding from this Azure Linux virtual machine to on-prem SQL Server. Now, in order to check the IP forwarding rules, I am using the iptables list command. Here, you should be seeing one DNAT rule to forward the packets to our SQL Server and one MASQUERADE rule to accept the packets from the SQL Server. The next step is to create a load balancer. For that, I'm going to go to Azure Marketplace and select the load balancer. Let's give a name for our load balancer. Select the region. And for this queue, it is very important to select standards queue because the private link servers will work only with standard load balancer. It will not work with a basic load balancer. For the type, I am going to select an internal load balancer, leave the tier to regional, and go to the front-end IP configuration. In this section, I am going to click on Add a front-end IP configuration. Let's give a name for our IP configuration. Let's select the virtual network, and for the subnet, I'm going to select the front-end subnet. Let's leave the assignment to dynamic and availability zone to zone redundant and click add. Next, I'm going to select the backend pools. In the backend pool section, I'm going to click add a backend pool. Let's give a name for our backend pool. For the configuration, let's leave it to network interface card, which is NIC, and let's select the add IP configurations. And I'm going to select the virtual machine that I just created as my backend pool. Click add and click the save button. Now our backend pool has been added. As a next step, I'm going to select the inbound rules. Let's click on add a load balancing rule. Let's provide a name for our load balancing rule and leave the IP version to IPv4. Select the front-end IP address and select my front-end IP, which we just created in the previous step. Expand the backend pool and select the my backend pool that we just created in the previous step. Let's leave the protocol to TCP. In the port number, let's enter 1433, which is the default port for SQL Server. And in the backend port, I'm going to use the same port number as 1433. For the health probe, I'm going to create a new health probe. Let's give a name for this health probe. Leave the protocol to TCP. And in the port number, I'm going to select port 22, which is the standard port for SSH. And leave the interval to 5 seconds and click save. What this health probe does is it is going to reach this backend virtual machine on port number 22 every 5 seconds. And it is going to check if it gets a response from that machine. If there is no response, the load balancer will assume that the backend node has been dead and report a failure. Leave the other options to default and click save. So what this load balancing rule does is, for any request that it receives on port 1433, it sends the request to the available backend machine on port 1433. Next, select the outbound rule. For our setup, we don't have to create any outbound rule because our virtual machine is going to forward the request back to our SQL server. It is not going to connect to internet. So we don't need any outbound rule. And hit review and create, and it's time to create our load balancer. Now our load balancer has been successfully created. Now the next step is to create the private link service. For that, I'm going to go to marketplace again and search for private link service and select the option private link service, your service. Let's provide a name for our private link service and select the region and go to outbound settings. In the outbound settings, for the load balancer, I'm selecting the load balancer that we just created, and for the front-end IP address, I'm selecting my load balancer front-end IP that we just created, and for the source NAT subnet, I am selecting the PLS subnet that we created in our VNet. Let's leave the rest of the options to default, and let's go ahead and create our private link service. Now, our private link service has been successfully created. The last and the final step is to create the managed private endpoint in our Synapse workspace. Now I'm in my Synapse workspace. I'm going to click on Manage and go to Managed Private Endpoints and create a new Managed Private Endpoint. Let's scroll all the way down and select Private Link Service and click Continue. My on-prem SQL PLS and select the private link that we just created. Let's click on New under Fully Qualified Domain Names, and here we have to provide the fully qualified domain name of our on-prem SQL Server. I'm going to provide the name of my on-prem SQL Server and click Create. It's going to take a few minutes to provision this managed private endpoint. Now, after a couple of minutes, I can see that my managed private endpoint has been successfully provisioned, but it is pending for approval. For this, I'm going to go into my private link service and go to private endpoint connections and select the managed private endpoint connection and click approve. Now my connection has been approved and it's ready to use. Now it's time to go ahead and test this connection. For that, I'm back in my Synapse workspace. I'm going to head over to my linked services and create a new linked service. From here, I'm going to select SQL Server, click Continue. I'm going to name it as my on-prem SQL, and I'm going to select Auto Resolve Integration Runtime, which is running in a managed virtual network. In order to test this connection, we need to enable the interactive authoring. For that, I'm going to click on Edit, go to Virtual Network, and enable interactive authoring. Enabling this interactive authoring is going to provision a virtual machine with integration runtime inside the managed virtual network. And note, we have already created a managed private endpoint to our private link service inside the managed virtual network. So this virtual machine with the integration runtime will be able to reach our on-prem SQL server via this managed private endpoint. And we are going to test that out. And now we see that our interactive authoring has been enabled. In order to connect to my SQL server, I have to provide the name of my on-prem SQL server. It is very important to note that the name of the SQL server matches the FQDN or the fully qualified domain name that we set up in our managed private endpoint connection. Let's go ahead and provide the database name and provide the username and password and click Test Connection. And voila, we can see that the connection test has been successfully completed. So let's go ahead and create this linked service. Now our linked service to our on-prem SQL server has been successfully created and ready to use. Now it's time to go ahead and start our notebook development. Now I'm in my Synapse workspace. I'm going to click on Develop, select Add a new notebook. Let's name our notebook On-prem to Fabric One Lake. I'm going to attach it to my Spark pool. Now, in this section of the code, I'm specifying my connection details to my on-prem SQL server. The server name should match the fully qualified domain name that we specified in the managed private endpoint connection. And I am also specifying my database name, table name, username and password. In the next section, I am reading the data from my table using spark.read into a data frame. And finally, in order to write my data into the Fabric One Lake, I go to my Fabric workspace, open my Lakehouse, click on Table Properties, and copy this ABFSS path. Now I'm back in my notebook and specify this as my One Lake path. And finally, I'm using dataframe.write function to write my data from on-prem SQL Server into Fabric One Lake in Delta format. Now it's time to go ahead and execute our notebook. And our notebook has been successfully executed. Now let's head over to our Fabric Lakehouse and click refresh on the table section. And I can see my customer table has been loaded from on-prem SQL Server into Microsoft Fabric. This concludes our video for today. Hope you all enjoyed this video. If you have any questions on Fabric, please comment below and I would love to answer them. See you on next one.